Hello, physics friends. Today we're going to take some notes on velocity versus time graphs. So the graphs we've been looking at so far have all been position graphs. So we know a position graph because we have the variable x versus t. We're going to start looking at velocity graphs, and we know it's a velocity graph because we put v versus t. You could spell out velocity as well. We're mostly going to just be doing sketches for today. That's why I don't have any numbers on this axis. We might put some on there in a little bit to help us out. So let's think back to our first lab experience when we went outside and you walked down the sidewalk and you found your constant velocity. I'm pretty sure that most of us ended up with a graph that looked something like this for our position graph. By the way, that's supposed to be a straight line. It's my best straight line I can do with this app. Okay, now we know after looking at this position graph, we know that when we see a straight line like this on a position graph, we know that that represents an object moving at a constant velocity. So here's my question for you. How is the graph going to change when we look at a velocity versus time graph? Is it going to be still an inclined line? Is it going to be a horizontal line? Is it going to be a vertical line? Is it going to be an inclined line in a different direction? Think about that for a second. Go ahead and pause the video and make a guess, make a prediction, and when you come back, we'll talk about it. Okay, did you make your prediction? I will tell you that most people, they make a prediction that looks like this. It's still an inclined line. Unfortunately, most people, before they really start learning some physics, they would be wrong. That is incorrect. That is not what a velocity graph is going to look like. So let's think about this for a second. And let's go ahead and let's talk about some numbers. And let's assume that at 1 second of time, the person had traveled 1 meter. And at 2 seconds of time, the person had traveled 2 meters. And at 3 seconds of time, the person had traveled 3 meters. We would know then that their velocity for that is 1 meter per second. And it doesn't change, right? They're always going 1 meter per second. We know that that's constant velocity. Now let's talk about what that's going to look like in the velocity versus time graph. We know that at all times, 1 second, 2 seconds, 3 seconds, their velocity is always 1 meter per second. So if we were just to put data points, it would look like this. So our line then would look like that. So now this horizontal line represents a constant velocity. What does a horizontal line represent? And let me go ahead and change colors. What does a horizontal line represent on a position graph? That's my best horizontal line. Is that person moving? They're not. So what's their velocity if the person isn't moving? Hopefully you know that their velocity is 0. Well, if the person is not moving and continues to not move, and their velocity is 0, that means their velocity graph is going to look like that. So let's take a look here. No, not moving in a position graph means you've got a horizontal line. Not moving on a velocity graph means you've got a horizontal line on the time axis. Now, what if we ask another question? We say, well, what if there's another person? And that person is moving quicker. They're moving not at 1 meter per second, they're moving at 2 meters per second. What would that look like on the position graph? Hopefully you realize it would look something like this. It would still be a straight line. It would just be steeper. It would have a bigger slope. Now, what would that look like on the velocity graph? Well, it would still be a horizontal line, but it would be higher, representing the idea that there is a larger velocity. All right, I've got one more for you. Okay, and these are pretty tough, so we're going to work on this for a while. One more. What if now the person is moving backwards? So here we've got no motion. Here we've got moving forward at a constant velocity. Here we've got moving forward at a larger constant velocity. Now we're moving backwards. What is that going to look like on our position graph? That's going to look like this. That's supposed to be a straight line. You figured out by now I do not draw straight lines very well on an iPad. What is that going to look like in our velocity graph? Take a guess. Is it still going to be horizontal? I hope you said yes. The difference now is that let's take a look at this slope. This is a negative slope. In math class, we talked a lot about slope, right? This is a negative slope. That's a negative velocity. That means that constant velocity is going to be down here. So we're going to keep that in mind as we look at some examples. We're going to do one, maybe two together, and then you're going to have some time to practice on your own. So let's take a look at this first example. Okay, it says draw the velocity versus time graph that corresponds to the position versus time graph below. Now this is pretty complicated because we have three distinct legs. So I would say that this is one leg, and I'm going to go ahead and put that in red. I would say that this is another leg. I'm going to put that in blue. And this is the last leg. I'm going to put that in green. So I have to look at each distinct leg separately. So let's take this red leg first. Okay, let's take a look at this. Now, I can tell, and it's hard to tell because the print is really small, but hopefully you can tell that the velocity here is a constant velocity because it's a straight line, and that the velocity, and I can tell this by looking here, this is 2 meters, right, in 1 second. So I can tell that the velocity here is 2 meters per second. And it doesn't change for the first, let's see, 1, 2, 3, 4 seconds. It's always 2 meters per second. So on the velocity graph, oh my God, I want to move this up a little bit. On the velocity graph, I can draw that by drawing the horizontal line for the first 4 seconds at 2 meters per second right here. Now let's go ahead and let's look at what I shaded in blue on the position graph. I look at this and I know the slope of a horizontal line. Hopefully you remember that the slope of a horizontal line is 0, so this velocity is 0. Right? This person isn't moving at all, they're standing still. That's very similar to the green line we had up here. So this velocity is 0 from 4 seconds to 5 to 6 seconds. So we can go ahead and we can draw that on our velocity graph. It's going to look like this. Now, it looks kind of weird for a graph, right? Because there's nothing connecting the red line to the blue line. That's okay. They don't have to connect. Okay? We're going to talk as we go forward how this is not really possible in the real world, right? That looks like this person is going right from 2 meters per second to instantly stop. That's how this slope changes instantly. We know that's not possible. You have to slow down from 2 meters per second to stop. But it happens pretty fast, which is why we're able to have this corner here and why we're able to have this kind of disconnected junction here, okay? All right, let's take a look at our last section here, our green section up here, okay? Now, the first thing I want to realize is that this velocity is going to be negative. How do I know? Because the line is going down. So I look at this and I try and say, well, okay, I got to find the slope here. What's the slope of this guy going to be? Well, let's see. Rise over run. So he goes, let's see, 1, 2 meters, right? Because he goes from 6 meters to 4 meters from, let's see, 6 seconds to 12 seconds. So in 1, 2, 3, 4, 5, 6 seconds, he goes 2 meters. So that velocity, check my math for me, is 1/3 of a meter per second. But remember, it's negative. So I got to have that negative 1/3 meter per second. So does it change at all in that time period from 6 seconds to 12 seconds? It does not. Now I have to do a little estimation here. So I know it's going to be right around here. Oh, that is not a very good horizontal line. I did my best. Notability is easier. I just can't use Notability when I'm videoing like this, okay? So there is my velocity graph. Pretty straightforward. So a couple of key things to remember. 1, break up the position graph into constant velocity parts, right? What's happening between 0 and 4 seconds is all the same. So this is kind of leg 1, this is leg 2, this is leg 3. Then realize that this straight line means it's a constant velocity on the position graph, and I show a constant velocity on a velocity graph by a horizontal line. That's how I know this is going to be horizontal. Then if you can figure out the velocity from the slope, go ahead and do that, right? All we did was find the slope of this line. We found the slope to be 2 meters per second, so we know the velocity is 2 meters per second. And you do that for each of the individual legs. All right, what do you think? Do we need to try one more together? Why not? Let's give it a go, right? All right, so let's take a look here at this next one. And let's go ahead and break this down into 3 legs. So I'm going to have leg 1 in red, I'm going to have leg 2 in blue, and I'm going to have leg 3 in green. Now what I suggest is that you go ahead and you try this before you watch the rest of this video. So pause the video right now and try and go ahead and graph the velocity graph. And then when you're done with that, start the video again and we'll go through it together. Okay, so pause the video now, try it on your own. All right, how'd you do? I hope you did great. All right, so let's take a look. So we've got constant velocity for this first one here. I know the velocity is going to be negative, so I'm going to say right away, oh, I've got the wrong color there, undo. So I look at the velocity and I say, okay, rise over run. Let's see. We're going to go from 4 meters to negative 2 meters. So let's see, that's 6 meters in 2 seconds. 6 divided by 2 is 3. This velocity must be negative 3 meters per second. So I can go down here, negative 3 meters per second. I got to move my graph up a little bit, is right here for that first 2 seconds. So there is my horizontal line. Okay. Then I can look at my second leg. Again, I'm looking at rise over run. Now, one thing I want you to be careful about, because some of you in your math class, you learned for rise over run to count boxes. And if you did that in this case, you would come up with the wrong value. Why? Because look here, our position, each box is 2 meters. But our time, each box is 1. So if you counted boxes, so let's go back to this red one. If you counted boxes, you'd say, oh, okay, well, I want 1, 2, 3 boxes down, 1, 2 boxes over, so the velocity must be 3 divided by 2, or 1.5. But that would be wrong, because this goes from 0 to 2 to 4 to 6 to 8. So do not just count boxes, okay? Now, I can see that each of these boxes are worth 2 going up, so I can go ahead and I can see, well, I'm going from negative 2 all the way up to 8. So that's, let's see, 2, 4, 6, 8, 10. So that's 10 meters in 1, 2, 3, 4, 5 seconds. So velocity here, 10 meters in 5 seconds, must be 2 meters per second. And it's positive because that's a positive slope. That line is going up from left to right. So I can go back here and I can say, all right, my velocity is 2 meters per second until we get to this time at 10 seconds right here. So that's going to be that line right there. You kind of need to do those sound effects, or physics is not nearly as fun. Okay, let's take a look now at our last leg, our last segment. This velocity, nice and easy, because I know the slope of a horizontal line. This slope is 0, yay! So now, 0 velocity, that's this guy right down here. See, sound effects make it more fun. Okay, so that is my velocity graph. So we've got several other pages. If you take a look, we've got several other pages. So what I would like you to do now is try those on your own. I will eventually post a key. We will go through it in class if you're not absent anymore, and then you will be able to check your work, and I think you will have done great. Just if you need some more help, take a look at these, and if you still don't get it, come in and see your teacher. Thanks for watching. Have a great day.